Merry Christmas, everybody. I hope you're doing well. You're looking at an artistic website or artistic video or artistic frames brought to you by mostly photography websites. They're showing you different examples of lens anomalies and lens flares that people want in their photographs in order to enhance the lighting. It brings out some interesting effects, sometimes even colors, depending on what filters you're using. And, you know, colorful, bright, starry things. It just seems kind of Christmassy. So, yeah, I wanted to show you some examples. The interesting thing is most of these are created by floodlights, but are identical to what you see when people take pictures of the sun. So some of these are the sun, and some of these are not. Maybe you can figure out which ones. I can't. But you see the little discs, the little orange, yellow discs? Those showed up in the midst of 1,800 frames that we had strung together, 1,800 frames from stereo A to show you the transit of Mercury in that satellite. And of course there was a solar flare, and right after the solar flare there was a single frame with this anomaly on there, and we went back and studied it because we look for stuff like that and determined it wasn't worth wasting your time. So if somebody made a video about this very anomaly on a stereo A satellite, I'm sorry, they wasted your time. And many, of these circles you see before you in color and shade, many of those are actually reflections. They're not even lights. That's a street light lens anomaly. Depending how many filters and how many pieces and layers of glass you have between the actual developing surface and the light source, you can create layered anomalies. Glass is translucent. And you can alter the colors you see, but this very anomaly you've seen before. I know you've seen it before because somebody may have represented it, or I should say misrepresented it, as being something other than just a lens anomaly on glass. You see, we've been tracking a brown dwarf in the solar system. We've made over 250 to 300 earthquake solar flare weather predictions, even tide predictions based upon where this brown dwarf is. And all of those were right. So I think zero wrong means zero wrong. 100% is 100%. So I think we know what the heck we're talking about. And this picture here is probably the most convincing. At the 2 o'clock position, you barely see an off-colored orb slightly, and then off to the lower left, you see 3 spheres chasing after it. Those are traveling in a clockwise direction, chasing after that giant sphere. And as our eyes can see, there's still a lens anomaly happening with the apertures and the aperture blades, making the sun appear like a star. But those 3 objects are seen as almost like you would a crescent moon or a new moon as they pass underneath the sun, about the same inclination that Robert Harrington predicted. Well, actually, folks, it's not April Fool's, but that actually was created by an artificial light source, and that came off a lens flare app. So depending on your focus, what you're focusing on, you can get hexagons, you can get trapezoids, you can get arcs, you can get streaks, you can get beads connected together, you can get beams, you can get different colors, different grids. It's amazing what light does when it reflects off of your lenses. And when you have more than one layer of glass, you can create more than one layer of anomaly. Some anomalies you see in this frame come off the outside exterior glass. Some come off the filter itself. When the sun's off to the side and kind of hits the edge of your lens, which is curved, that lens can reflect light back onto the lens itself from the edge. Look at the edges glow here. You see 3 separate anomalies. One has a change in color, kind of pink. And that reflects light back onto the lens. And it's set up by the curvature of one of the filters or one of the lenses. But people want to know what to expect from this brown dwarf. And if you think that those spheres next to the sun were brown dwarfs and we're still standing here talking about it, you're not going to, give too much of a hoot to even look for what's happening. But the sun has been not quite as hot and stingy in the last month as it has been. And that I'm in the northern hemisphere, so chime in. Southern Hemisphere. Come on, Australia. Let us know what the sun has been doing and is currently doing. But we're looking for a sudden brightening of the sun, and I've seen the sun brighter the last 2 days than it's been, even though there's been clouds. It's just a little less comfortable, and that's what you're looking for. If this brown dwarf is going to cross up from underneath the solar system, cross the plane of the solar system, right around that moment of crossing the plane of the solar system, it's going to exert its greatest effects upon the sun, meaning shedding particles. And those particles will get here in a delayed reaction, and at about 300 kilometers a second out by the asteroid belt, it could take a few days for those particles to get here. So when the sun does brighten, it's a symptom that's a few days past. You've already lost time waiting to check for the sunlight to suddenly brighten. But you can expect that to be happening if this thing crosses our ecliptic. And unfortunately, it's not going to tell you when. It's going to tell you when, because by the time the particles get here, this thing is going to be moving at 400 kilometers a second, possibly. We got an average speed of 260 kilometers a second of this brown dwarf. But also the zodiac light you should be looking for. Don't mistake it for the chemtrail reflections. But you want to make sure you're a good 2 to 3 hours before sunrise or after sunset. And you want to look for a glow that's not quite white. You're looking for a glow that's more of a chocolatey purple color and faint. And we were told once upon a time, at least I thought, tell me if I'm wrong, you guys. I was told that our average interplanetary void in space measured 10 cosmic rays for every cubic meter. Now they're reporting 5 per cubic centimeter particles. Up to 100 particles per cubic centimeter, and that's when we have CMEs. So this actually was derived with the understanding that most of these cosmic rays they're measuring are supposed to be coming from the sun, because nobody's talking about the second sun, but they're talking about the interplanetary medium. It's supposed to be very low, they say. Well, 5 particles per cubic centimeter And I bring to you, as your Christmas gift, one of the last glances you'll ever see of an instrument that's measuring cosmic ray helium. Every other one I've ever shown you is no longer available or no longer reliable. I will not tell you where this is, but there's some irregularities on this. You see a log scale goes from 0.1 to 10. So there has to be 10 to the 0, but for some reason they scratched out the integer. They scribbled it out, which kind of, on a scientific instrument, it makes scientists go, what the heck is that? Why can't somebody just go in and make it 10 to the 0, which would be 1? So this has measured, depending whether you're doing cubic centimeters or cubic meters, this has measured an 80% increase in the last 3 to 4 years. this helium instrument. Don't expect to see it anytime soon, because once I show it, it's probably going to go away. And I'm sorry, but it's showing you what's happening. Relying on the helium is not going to be a very good advanced warning. The advanced warning is going to be the magnetics. And that's a whole nother video. So we did a lot on the Mercury transit. Mercury crossed in front of Leo. That's why we were looking at stereo A, and we're still looking at stereo A, looking for any anomalies out in that direction. But then the protons started disappearing in the solar system, and there's only two ways protons can disappear, and that's if the sun quits fusing hydrogen into helium, which it's not doing. It sure seems bright and fusion-y to me. And that's if there were cosmic rays in the solar system that would absorb those protons or that hydrogen. There goes your protons. Every single time this cloud of hydrogen, or waves of hydrogen, tries to filter through a wave of helium, the helium-3 grabs on to that proton as if it were a chocolate sundae and the helium-3 was a little kid due to absorption. So then we showed you how certain planetary tables didn't even agree with each other anymore. People couldn't agree on where the planets were supposed to be, and it's just because somebody was using an older table. And that's not supposed to matter. You're supposed to be able to calculate thousands of years in advance where the planets are going to be and the moon's going to be. And we've showed you and we've chronicled the steady loss of the oceans, both Fukushima and the warming of the oceans. And millions of trees are dying, and if you just, Google's hard to find doom and gloom on. They're kind of burying that stuff. But if you want to really find out what's going on, you have to use Bing or even Yahoo search and type in dying trees, and you won't get a bunch of horticultural stuff from your local nursery. You'll get a real story about the trees dying, which is carnage. And the carnage is everywhere. And we try not to show you too much, and we waited till after Christmas to show you the carnage and remind you what carnage is and what carnage looks like. All of it can be attributed to the increased radiation and heat. Even gamma radiation. Holy cow, we didn't think the sun produced gamma radiation, and it really doesn't. It's the corona of the sun that's producing gamma radiation. And there you see a map. That's a gamma ray map. That little yellow dot in the middle is the sun. Yes, that's from particle interaction. When helium-3, hot helium-3 and hot helium-4 crash into protons. And then electrons go flying about and crash into. It's a reaction from hell in that corona, and that would bring your ice packs down. It would warm your oceans, and you would have to see that for any of that to even be true. So when you go and you look at the oceans, and when you go and you look at the ice packs, you get to see that all this radiation you're feeling isn't your imagination. You see it in the graphs, you see it in the instruments, and you see it when you just open your eyes and go looking around. So then once we had proven the cause, we wanted to go back and make sure the symptoms were still there and the warmest oceans ever recorded. Well, we know what absorbs energy. Water does. And we see that if the oceans were warm, the ice has certainly responded, especially in the Arctic. The methane has gone through the ceiling. And we look at the sun and we see the radiance didn't care for 15 years, the last 15 years, what the sunspot total was. That was visible light. So if the sun appeared brighter, there's your proof it was. We see more electrons coming in, a total electron count. When we get those, our magnetosphere expands. And that's what happened in January, like we entered a pocket and came into a stream of electrons, and those just expanded our magnetosphere. That used to happen in mid-February. We also had earthquakes during this time. So it means it's time to get ready. Be responsible.